When NASA's Voyager 1 and 2 launched back in 1977, they started the biggest expedition an unmanned spacecraft has ever gone on. They dramatically reshaped our understanding of the solar system and how it came into being by traveling past all of the outer planets, well, apart from Pluto. However, the legendary probe's nearly 45-year interstellar mission is nearing its end as NASA continues to gradually shut down the systems on board the spacecraft. Is this the end of Voyager twin spacecraft, which have journeyed farther than anything constructed by humans? If so, what will be the next step in our cosmological exploration? Let's find out. NASA's Voyager 1 and 2 are running out of power. The two probes were launched in 1977 and have kept pushing the limits of space research ever since. The distance these probes have traveled from the planet Earth, further than anything ever made by humans, cannot be overstated. As a result, these explorers will probably continue to retain the record for the farthest human-made object for many years, if not a century. The Voyager twin spacecraft's mission was initially intended to last only 5 years when they blasted off from Earth in the 1970s. But when they got to Jupiter and Saturn, the plutonium-powered spacecraft was still going strong, so NASA engineers decided to undertake a flyby of Uranus and Neptune. However, the spacecraft continued to travel even after that, and they are still doing so many years later. So much so that both spacecraft made history by formally leaving the heliosphere, a bubble-shaped zone generated by the sun's wind, and entering interstellar space. And in order to extend the probe's lives by a few more years, a soft cutoff date of 2030 was established for power reductions. "We've done 10 times the warranty on the darn things," said physicist Ralph McNutt at the Johns Hopkins University Applied Physics Laboratory in a report concerning the unprecedented longevity of the probes expected to last 4 short years. Yes, you heard right, 4 short years. Therefore, the onboard power supply must be cut off since they are deteriorating. 4 of the first Voyager's instruments are still in operation compared to 5 on Voyager 2, and they are all fueled by the electricity created as plutonium decays. In 2019, engineers had to turn off the heater for the cosmic ray detector, a crucial piece of equipment for detecting when Voyager 2 exited the heliosphere, the magnetosphere, the astrosphere, and the outermost atmospheric layer of the Sun. This battery's output has been declining for about 4 watts every year, forcing NASA to make some difficult decisions about what to disable. The magnetometer and the plasma science experiment, which are located in the spacecraft's body, are probably the last equipment NASA will turn off. These are kept warm by the computer's waste heat, while the others are suspended on a 13-meter fiberglass boom, making it likely that they will take the longest to cool down. Surprisingly, the 2 spacecraft have managed to keep performing considerably below the temperatures at which they were tested. The fact that both Voyager spacecraft are still functioning after almost 50 years in space is proof of their extraordinary engineering prowess. This is amazing, but not entirely unexpected. The tiny onboard processors on both probes have a warm source of electricity from radioactive plutonium reactors that have kept them running non-stop for decades. Sadly, the break is approaching. In August, the Voyager Science Steering Group will decide on the next steps for controlling the power budget. The engineering team has come up with some innovative methods to keep both Voyagers performing as much science as they can for as long as they can. Even when traveling at the speed of light, radio communication from Earth to either craft takes more than 18 hours to reach Voyager 1 and nearly 22 hours to reach Voyager 2. The craft adds 3 to 4 additional light seconds to that period for each day as it travels farther, and that makes it more difficult for Earth to receive or hear the Voyager's signals. "Earth is a noisy place," says Glenn Nagel, Outreach and Communications Manager at the Deep Space Network's facility in Canberra, Australia. "Radios, televisions, cell phones, everything makes noise. and so it gets harder and harder to hear these tiny whispers from the spacecraft. The plan of the scientists' team might theoretically extend the power beyond the 2030s. However, NASA has not decided to cancel the mission, and both probes are still returning original scientific data. We also must underline how deeply original and important the science conducted by the spacecraft has been and continues to be. The Voyager spacecraft's utility has greatly surpassed astronomers' predictions. They are anticipated to enter interstellar space very soon, though it will take another 300 years for it to reach the end of the solar system. The probe's main objective was to do a flyby of Jupiter and Saturn. They succeeded admirably by providing the first detailed photographs of Europa, Ganymede, Titan, and other gas giants. But it may have taken more than 10 years to create the most important image. Guess what it is? You are perhaps wrong. It's the image of Earth taken by Voyager 1 in 1990 while it was 3.7 billion miles from the Sun. The pale blue dots, made famous by the late astronomer Carl Sagan, help to highlight how fleeting and delicate our entire existence is, from the conflicts of ancient civilization to our own petty political squabbles and the exploitation of the planet's ecosystem to the present. It was all there, in a microscopic blue speck amid a vast, seemingly indifferent, dark world. The human race has only existed for a relatively brief period in the history of the cosmos on a small, vulnerable planet that won't be around for very long. If we are to take anything away from the famous probes, it should be this. And the entire world is beckoning us to leave our human arrogance comfort zones and embark on the biggest journey ever. As a young population of sentient beings, Voyager 1 and 2 have been, and will continue to be, our hesitant first step into cosmic adulthood. So what comes next? NASA needs a replacement. This time, the next interstellar mission will be built from the ground up to last for a very long time. The new mission's designers, physicists at the Johns Hopkins University Applied Physics Laboratory, APL, think the Voyager replacement might last for more than a century. The Interstellar Probe, a brand new initiative, might launch in the 2030s. It is designed to go farther and faster than any other artificial object has, and is likely to go in the near future. The spacecraft is expected to go to one or more of the 130 known dwarf planets in the extreme limits of the solar system while it is still in our solar system. Some indications point to the possibility that some of these cold worlds originated as ocean worlds. According to the early design predictions, the interstellar probe should travel at least twice as fast as Voyager 1, which should enable it to cover about 375 astronomical units, that's 34 billion miles, in its first 50 years. The spacecraft could end up traveling more than 800 astronomical units, or an astounding 74 billion miles if it is able to continue traveling for another 50 years. That distance isn't very far by astronomical standards, despite being amazing. Remember that Proxima Centauri, the star nearest to our solar system, is located approximately 25 trillion miles away. We are so far behind the technological accomplishments that are casually anticipated in science fiction and popular media that it would probably take more than 30,000 years to go to Proxima Centauri using our current technology. But you have to start somewhere. Thus, NASA intends to maintain a presence in interstellar space. Interstellar missions are very different from anything NASA or any other space agency has undertaken in the past. They won't necessarily be more technically difficult than sending a human to the moon or running a rover on Mars. Still, they will outlive the initial mission's crew because of their lengthy timeline. As the scientific torch is passed to a new generation of researchers, this presents a unique set of difficulties. In order for engineers to have the debugging resources necessary to address a potential problem even 100 years from now, the mission will also need to store spare hardware components and the software they are now coding in a safe manner. It's important to plan ahead, which may require thinking the unthinkable. Scientists aim to attach some new Easter eggs to the projected mission, which has an estimated cost of $1.5 billion and is still in the planning stages. On the off chance that one of the Voyager spacecraft would be discovered by an advanced alien race, each one was equipped with a golden record. Each disc transmits greetings from the inhabitants of Earth through sounds, images, and recordings. The audio recording contained a variety of musical selections, including Blind Willie Johnson, Beethoven, and Chuck Berry. Stella Ocker, a graduate student at Cornell University who works with Voyager data, said, "I don't think we should try to copy the golden record, but I think it would be really amazing to have a similar kind of public outreach piece that plays an important part in the mission." Don't you agree? The James Webb Space Telescope, which is already well known for its captivating photographs of the cosmos, has succeeded once more. With its first image of Neptune, NASA's James Webb Space Telescope displays its capabilities closer to home. In addition to providing the best glimpse of the planet's rings in more than 30 years, Webb's cameras also shed new insights on the ice giant. The clarity of the planet's rings, some of which have not been seen since NASA's Voyager 2 became the first spacecraft to examine Neptune during its approach in 1989, is what stands out most in Webb's latest photograph. The Webb image vividly displays Neptune's fainter dust bands in addition to many brilliant narrow rings. According to Heidi Hamill, a Neptune systems specialist and transdisciplinary scientist at Webb, it has been 3 decades since we last observed these faint dusty rings, and this is the first time we have seen them in the infrared. These incredibly weak rings were discovered so close to Neptune thanks to Webb's exceptionally consistent and accurate image quality. Since it was discovered in 1846, Neptune has captivated scientists. Neptune orbits in the distant, dark area of the outer solar system, 30 times further from the Sun than Earth. High noon on Neptune is comparable to a dull twilight on Earth because of how small and pale the Sun appears from such a great distance away. The internal chemical composition of this planet qualifies it as an ice giant. Neptune is substantially richer in elements, heavier than hydrogen and helium, than the gas giants Jupiter and Saturn. Small concentrations of gaseous methane enable Neptune to appear characteristically blue in Hubble Space Telescope photos at visible wavelengths, which is easily observable. Neptune does not seem blue to Webb because his near-infrared camera, NIRCam, only sees objects in the near-infrared spectrum between 0.6 and 5 microns. In fact, the planet is fairly black at these near-infrared wavelengths due to the substantial absorption of red and infrared light by methane gas, with the exception of areas with high-altitude clouds. These bright streaks and spots of methane ice clouds are noticeable because they reflect sunlight before it is absorbed by methane gas. Over the years, images from other observatories such as the W.M. Keck Observatory and the Hubble Space Telescope have captured these rapidly changing cloud features. A more discrete visual indicator of the worldwide atmospheric circulation that fuels Neptune's winds and storms could be a thin line of brightness circling the planet's equator. At the equator, the atmosphere lowers and warms, making it light at infrared wavelengths more than the nearby cooler gases. Neptune's northern pole, near the top of this image, is just out of sight for astronomers due to its 164-year orbit, but the Webb images suggest an unusual brightness there. Webb's image clearly shows a previously known vortex around the southern pole, but this is the first time Webb has shown a continuous band of high-latitude clouds surrounding it. 7 of the 14 known moons of Neptune were also discovered by Webb. A very brilliant point of light with the distinctive diffraction spikes observed in many of Webb's photographs dominates this Webb painting of Neptune. However, this object is not a star. This is Triton, the big and strange moon of Neptune. Triton reflects about 70% of the sunlight that it receives thanks to a frozen coating of condensed nitrogen covering it. Because methane absorbs at these near-infrared wavelengths, it outshines Neptune by a significant margin in this photograph. Triton's peculiar retrograde orbit around Neptune has led astronomers to hypothesize that this moon was once a Kuiper Belt object that was gravitationally grabbed by Neptune. Additionally, the James Webb Space Telescope has taken its first pictures of Mars by sensitively observing infrared light originating from the planet. On September 19th at the Europlanet Science Congress EPSC 2022, the first photos and spectra of Mars from the James Webb Space Telescope were made public. On September 5th, 2022, JWST took the pictures and measurements from its approximate million-mile, that's 1.6 million kilometer, distance from Mars. The images of Mars's observable disk, or the side of the planet facing the telescope that is illuminated by the Sun, were taken by Webb's near-infrared camera, NIRCam. They could offer planetary scientists a distinctive perspective of Earth's close neighbor and deliver data that can be used in conjunction with observations made by rovers like NASA's Perseverance and objects in the Martian orbit. It is not the simplest object for the JWST, which is designed to observe extremely distant and dim objects to see, because Mars is relatively close and highly bright. Astronomers can study short-term phenomena like Martian weather patterns, dust storms, and even changes brought on by the planet's seasons, thanks to the JWST's ability to take images and spectra with the spatial resolution they require. The Webb telescope also allowed for simultaneous observation of events that take place throughout the Martian day, including throughout the day, sunset, and night. The eastern hemisphere of Mars is depicted in two different wavelengths of light in the JWST's initial photos of the planet. The reflected sunlight dominates the short wavelength image, which depicts elements of the Martian terrain that mimic those observed in visible light. These features include the Syrtis Major Planum's dark volcanic rock and Huygens crater, a nearly 280-mile wide, that's 450 kilometer, impact crater. The light that Mars releases at longer infrared wavelengths as it loses heat was captured by the NIRCam camera on the Webb Satellite Telescope. The brightest and warmest region of this light is seen where the Sun is practically directly overhead the planet and is correlated to the temperature of Mars and its atmosphere. The brightness decreases in the northern hemisphere of the planet, which is currently experiencing Martian winter, and in the polar regions of Mars that receive less sunlight. However, the amount of light that reaches the JWST is not solely dependent on the planet's temperature. The chemical makeup of the Martian atmosphere and surface can also be inferred from the telescope's photos. Astronomers may be able to learn more about Mars's atmosphere and surface by using data from the James Webb Space Telescope to analyze the spectrum of light that was identified coming from the planet. Even during the warmest part of the Martian day, the 1,200-mile or 1,930-kilometer Hellas Basin seems darker than its surroundings, according to an analysis of the JWST photos. This impact structure's apparent darkening is the result of light entering the Martian atmosphere and being absorbed by carbon dioxide. The new photographs also show how the James Webb Space Telescope may investigate Mars using measurements made with the telescope's near-infrared spectrograph, NIRSpec instrument, a method known as spectroscopy. Planetary scientists can use spectroscopy to analyze the fingerprints that different chemicals leave in the light flowing from a planet's atmosphere to establish its composition, since chemical elements absorb and emit light at very particular wavelengths. The scientists' initial findings reveal spectral patterns that are encoded with details about Martian dust, frozen clouds, all of which make up the atmosphere, and the kinds of minerals that can be found on the planet's surface. Water, carbon dioxide, carbon monoxide, and other chemical components should be detectable by JWST observations. Methane is significant because it can inform planetary scientists about a variety of geological processes occurring on Mars, including whether or not a significant object has recently struck the red planet from space. Methane may also provide evidence of past biological activity on the planet. The first clear indication of carbon dioxide in an extrasolar planet's atmosphere has also been recorded by the Webb Telescope. The discovery not only offers intriguing clues as to how the exoplanet developed, but it also serves as a preview of what to expect when Webb investigates more and more extraterrestrial planets. The discovery is shown in a data plot that lacks the brilliance of Webb's earlier photos, which featured galaxies caught in a cosmic dance and dazzling clouds in a star nursery. However, the data are beautiful, according to Jesse Christensen, an astronomer at the NASA Exoplanet Science Institute at the California Institute of Technology in Pasadena. The exoplanet WASP-39b is known as a hot Jupiter by scientists because it has a diameter similar to Jupiter but orbits its star much more closely than Mercury orbits the Sun, making it extremely hot. The plot or spectrum provides detailed information about the atmosphere of the exoplanet. The planet, which is more than 200 parsecs away from Earth, was first spotted through ground-based studies in 2003, and it was later found by NASA's Spitzer Space Telescope, which was operational from 2003 to 2020. Although the latter's data were inconclusive, they did raise the possibility that WASP-39b's atmosphere contains carbon dioxide. Webb then came into the picture. On July 10th, the infrared telescope tracked the planet as it moved across the face of its star for a little over 8 hours. During this period, sunlight penetrated the atmosphere of the planet and was absorbed by distinct molecules at particular infrared light wavelengths. Scientists questioned whether carbon dioxide would manifest itself as a visible blip in the spectrum. Natalie Batala, an astronomer at the University of California, Santa Cruz, UCSC, is the team leader for Webb's Transiting Exoplanet Early Release Science. And there it was, just jumping off the computer screen, she says. The outcome has increased confidence that Webb will be a game changer for exoplanet research. The telescope is ordered to observe 76 exoplanets in its first year of operation alone. The total might reach hundreds throughout the course of its lifetime. It will peer through the atmospheres of small, potentially Earth-like rocky worlds and gas giants. Finding carbon dioxide, though, is impressive in and of itself. One may reasonably anticipate that a planet like Jupiter, which sprang from the same disk of matter as its star, would share the star's chemical composition. But neither for WASP-39b nor for our solar system is it the case. Strong carbon dioxide signals from the exoplanet indicate that it is loaded with elements heavier than the hydrogen and helium that normally make up stars. Why is the issue at hand? The narrative then begins to pick up steam. It's probable that comets and asteroids hit WASP-39b when it was young, delivering heavier elements like carbon and oxygen. It's interesting to note that the exoplanet appears to contain the same quantity of heavy elements as Saturn, which astronomers believe likewise had a turbulent youth. Alternatively, it's possible that WASP-39b evolved from elements in the icy outer limits of its planetary system before moving inward. When it reached its ultimate resting place, it was close to its host star, which may have blasted away part of the hydrogen from the exoplanet's atmosphere, concentrating the heavier elements and enriching them with carbon dioxide. 4 articles that will examine these possibilities and analyze the planet's spectrum in a lot more depth are now under development by scientists. Finding carbon dioxide in a planet's atmosphere is the first step in finding life outside of Earth. WASP-39b is considered too close to its star for it to support life, according to astronomers, who also do not anticipate it to. They don't even anticipate the Webb Telescope to discover undeniable evidence of extraterrestrial life. Carbon dioxide and methane in a planet's atmosphere are thought to be signs of life according to astronomers. In the end, finding life will probably call for an observatory considerably more sophisticated than Webb. But for us to be prepared for that technology in the future, we must get through this incredibly crucial era. On the other hand, the Hubble Space Telescope has made a significant advancement in its quest to determine the rate at which the universe is expanding, which is consistent with the notion that something weird is going on in the cosmos. Astronomers have recently utilized telescopes like Hubble to precisely measure how quickly the cosmos is expanding. But as those measurements have improved in accuracy, they have also revealed an oddity. When compared to observations made just after the Big Bang, there is a significant difference in the rate of the universe's expansion as it is now. That disparity is beyond the comprehension of scientists, but it implies that something unusual is happening in our cosmos, which might be the product of brand new undiscovered physics. For the past 30 years, Hubble has been accumulating data on a collection of milepost markers in space and time, which can be used to monitor the speed of the universe's expansion as it gets farther and further away from Earth. According to NASA, it has now calibrated more than 40 of the markers, enabling even more precision. The Nobel Prize winner Adam Rees of the Space Telescope Science Institute, STSCI, and the Johns Hopkins University in Baltimore, Maryland, said in a statement, "You are getting the most accurate measure of the expansion rate of the universe from the gold standard of telescopes and cosmic mile markers." When American astronomer Edwin Hubble saw that galaxies outside of our own looked to be moving away from us and doing so faster, the further away they are from us, the search for a precise estimate of how quickly space was expanding began. Since then, scientists have been looking for a better explanation of that growth. This is a time of great discoveries, and we are here for all of them. The Hubble Space Telescope has seen a lot of strange things over the years, and this latest sighting of a bubble nebula with a truly unique structure has scientists intrigued for several reasons. There are a lot of amazing things in outer space. There are billions of planets scattered throughout the universe, as well as powerful black holes and incomprehensibly hot stars. While there are a variety of tools for discovering these things, the Hubble Space Telescope has consistently proven to be one of the best. Since its launch in 1990, the Hubble Space Telescope has made numerous discoveries that have aided in the discovery of the universe's mysteries. It's seen nebulas that send shockwaves through space, baby stars that are covered in gas, creepy dying stars, and so much more. We'll probably never know everything there is to know about space, but the Hubble Telescope brings humanity closer every day. The Hubble Telescope is helping us to go one step closer to understanding the mysteries of space. A planetary nebula in the Delphinus constellation is the subject of NASA's latest Hubble observation. A peak at the nebula, known as NGC 6891, is looking at a gigantic space bubble. The object has a spherical form in the middle with exquisite features. A bright yellow light shines from the center, while a blue gas surrounds the bubble. The tail behind the nebula is equally as fascinating as the photo itself, as is typical of Hubble's telescope findings. You might wonder why it's so fascinating. A spherical outer halo is what you see when observing the blue gas. To put it another way, NASA claims that it is expanding faster than the nebula inside of it, which is why it has grown so much in size. A white dwarf star lies at the heart of the nebula's golden core. In comparison to our universe's 13.8 billion year history, the nebula's outer halo is just around 28,000 years old, according to NASA's projections. As part of its research into the structures and distances of nebulae, the Hubble Space Telescope stumbled onto NGC 6891. Hubble discovered that the white dwarf star at the core of this nebula is responsible for most of the ionized gas in this nebula. This also explains the nebula's magnificent blue hue. As the energized electrons revert from their higher energy state to a lower energy state by recombining with the hydrogen nuclei, they emit energy in the form of light, causing the nebula's gas to glow, NASA explains. These Hubble images are significant for several reasons. On the one hand, they're breathtaking photos that show everyone on Earth the wonders of space. All someone needs to do is go to NASA's website to observe a beautiful nebula or a complex star. These images also assist scientists in learning more about space and finding answers to pressing questions. Learning more about the universe through Hubble, TESS, or any other telescope is an awesome thing, no matter how you look at it. And that's not all there is to know about Hubble Space Telescope and its bubble. A bright nebula known as N44 has caught the eye of astronomers despite its remote location in the Large Magellanic Cloud, one of our Milky Way's satellite galaxies. N44 is a massive cloud of gas and dust that spans 1,000 light-years and has been observed by numerous telescopes over the years. The presence of the N44, according to NASA, is still a mystery. What is it about this specific space cloud that is so stunning and mysterious? Among the most striking features of this particular cloud is the enormous void etched into it. N44 features a superbubble, which is a massive cavity that spans roughly 250 light-years from side to side, making it a 1,000 light-year wide bubble that surrounds Earth. Even though it is loaded with incandescent hydrogen gas, dark lanes of dust, huge stars, and multiple populations of stars of various ages, the most distinguishing characteristic of N44 is this gap known as a superbubble, which has been recorded by the Hubble Observatory. The chasm, which spans 150 light-years, should not be mistaken for an ordinary one. According to NASA's explanation, stellar winds could have caused gas to be ejected from the nebula's interior. It suggested that explosions may have carved out the hole in the rock. The gas may have been blown away by stellar winds emitted by huge stars in the bubble's interior, although this contradicts recorded wind velocities in the bubble. Another theory is that the expanding shells of previous supernovae shaped the cosmic cavern, given that the nebula is replete with enormous stars that would die in gigantic explosions, according to NASA. Because the nebula, which spans 1,000 light-years, contains stars of all ages, astronomers have discovered one supernova remnant near the superbubble and discovered a 5 million year age difference between stars within and at the rim of the superbubble, implying multiple chain reaction star-forming events. Due to its emission nature, the N44 nebula appears to be a beacon in the night sky, as its ionized gas cools down from its high-energy state to its low-energy state. The cosmic entity emits energy in the form of light. The deep blue area in the right-hand corner of the photograph is the brightest and hottest section of the nebula if you look closely. This superbubble image was captured during a study led by Victor Kassol of Heidelberg University Center for Astronomy of the massive young stars that populate the bubble's rim. According to their findings, Kassol and his colleagues discovered that these newborn stars are part of the nebula's various active star-forming zones. Nebulae are believed to generate stars when they are disturbed by external forces, causing them to collapse in on themselves owing to gravity. Were these star-forming zones merely the result of stellar winds squishing together gas molecules? Or are they the result of supernovae's growing shock waves? The answer is now unknown, but astronomers who can solve this puzzle will learn how this superbubble came to be. Even though it contains multiple big stars and one known supernova remnant, no one source perfectly explains how this bubble evolved. However, the Hubble projects didn't finish there either. Only the Hubble Space Telescope could see who was winning the cosmic tug-of-war between the large and small Magellanic Clouds, two dwarf galaxies that orbit the Milky Way. There has been an enormous amount of gas extracted from one of these dwarf galaxies by their gravitational attraction. With its immense volume of gas known as the leading arm, the Milky Way is devouring and nourishing new stars. That said, whose gas is being consumed and whose galaxy is pulling the strings? As the large and small Magellanic Clouds yank at each other, one of them has ripped out a massive amount of gas from its companion. This shredded and fragmented gas, known as the leading arm, is being devoured by the Milky Way and is feeding new star birth in our galaxy. It has now been determined, through Hubble data, which dwarf galaxy is pulling the strings. The leading arm is considered to be 1 or 2 billion years old and about half the size of the Milky Way. Its name derives from the fact that it's guiding the Magellanic Clouds in their orbits around the Sun. To what extent did this gas come from either Magellanic Cloud, and if so, where did it originate? It appears to be linked to the Large Magellanic Cloud at first view. The subject of what the leading arm is constructed of, however, has been explored differently. Is it the Large Magellanic Cloud or the Small Magellanic Cloud that it shares? Forensics took on a new meaning when scientists used Hubble's UV vision to examine the gas in the leading arm in detail. They saw lights from 7 quasars, which are the brilliant centers of active galaxies billions of light years beyond this gas cloud. Using Hubble's cosmic origin spectrograph, they measured how this light filters through the cloud. In particular, they were interested in the cloud's ability to absorb UV rays. These are reliable indicators of the concentration of the gas's heavier elements. Once they had Hubble's data, they compared it to other radio telescope measurements, including those made by the NSF's Robert C. Byrd Green Bank Telescope at the Green Bank Observatory in West Virginia. After a great deal of investigation, the scientists were able to match the leading arm's gas fingerprints with their findings. They discovered that the gas was consistent with that of the Small Magellanic Cloud. This suggests that the Large Magellanic Cloud is winning the tug-of-war as it has drained so much gas from its smaller neighbor. That's one of the many questions that have been answered by the Hubble Telescope's exploration of the cosmos. Hopefully, we'll have some more answers soon. Black holes are extremely dense regions of space that cause significant gravity drains. Beyond a certain point, even light cannot escape the powerful gravity of a black hole. And in a hypothetical process known as spaghettification, anything that approaches too closely, be it a star, a planet, or a spacecraft, will be stretched and compressed like putty. Stellar, intermediate, supermassive, and small black holes are the different categories. Star death is the most well-known way that a black hole can form. As most stars approach the end of their lives, they will enlarge, lose mass, and eventually cool into white dwarfs. The largest of these burning objects, those at least 10 to 20 times the mass of our Sun, will either turn into stellar mass black holes or extremely dense neutron stars. When big stars near the end of their lives, huge explosions called supernovae happen. Such a burst launches the interior of the star into space, leaving the central core behind. While the star was alive, nuclear fusion supplied a constant outward push that offset the gravitational pull of the star's mass inward. The star remnants of a supernova can no longer contain any forces to oppose gravity. The star core starts to collapse in on itself as a result. When an object's mass is compressed into an incredibly small point, a black hole is formed. Black holes' strong gravitational pull is a result of their ability to cram more matter, mass greater than the galaxy's sun, into a small area. These stellar mass black holes could number in the tens of thousands in the Milky Way galaxy. Why are black holes strange? According to Rocket STEM, the largest black hole so far found is 20 times larger than the solar system. While this far more massive object rotates once every 3 months, the outer planets of the solar system orbit once every 250 years. On its outside edge, it moves at a speed of half that of light. Like all black holes, the huge ones have an event horizon that blocks our vision of them. At its center is a singularity, a region of space where density is limitless. We are unable to understand the interior of a black hole because the laws of physics have been violated. Time is stopped at the singularity's event horizon, and gravity is unbounded. Stephen Hawking asserts that black holes are slowly dissipating. Long after all stars have died and galaxies have been obscured from view by the unrelenting expansion of the universe, black holes will be the only things left in the cosmos. Black holes can range in size from star remnants a few times the mass of the Sun to monstrosities tens of billions of times more massive, but nature has figured out how to make them all. That would be like equating the Great Pyramid of Giza with an apple. Black holes, which are matter tombs, are inaccessible to anything, not even light. In his book, A Brief History of Time, Stephen Hawking popularized the terrible process of spaghettification, which would be experienced by everyone who entered a black hole. Your bones, muscles, ligaments, and even molecules would be torn apart by the black hole's powerful gravity, which would cause you to become spaghetti-like. The author Dante portrayed the inscription over the gates of hell in his poem, The Divine Comedy, warning people to give up hope once they enter the region. By the way, astronomers recently found the black hole that is closest to Earth. It is located in the constellation Telescopium, a cool 1,000 light-years away from our planet. It's almost as though it's banging on our cosmic back door. The astronomical wonder in question is a member of the HR 6819 2-star system. According to astronomers, there might be many more of these elusive celestial objects lying in plain sight. Researchers focused the MPG ESO 2.2 meter telescope on HR 6819 in 2004 at La Silla Observatory in Chile. An outer B star and an inner star are the two stars that make up the stellar system. The star system may not be a typical binary star system, however, measurements made over 4 months discovered that the inner star appeared to be orbiting something at a very fast speed almost every 40 days. According to their estimates, such objects had to be large and massive, with a mass nearly equal to that of the Sun and an approximate size of the inner star. They then started to limit their selections. Telescopes would be able to clearly see a star with the same mass as the thing in the inner star's orbit. The likely offender? An extremely massive black hole. However, if the black hole is so close from an astronomical perspective, why has it taken so long to be discovered? Black holes are extremely dense objects that eat nearby stars as well as large quantities of gas and dust. They are frequently the remains of supernova dead stars. They have such a strong gravitational attraction that not even light can evade them. They are hence notoriously challenging to identify. However, sometimes there are obvious indications that black holes exist nearby. Black holes that consume neighboring matter leave behind radiation that telescopes can detect as proof of the feast. Black holes occasionally have an impact on the orbits of neighboring objects, causing astronomers to become aware of their presence. Other black holes that you might be familiar with are considerably farther away, such as Sagittarius A star, which is about 25,000 light-years away and is at the heart of our galaxy. The galaxy M87's black hole, of which we have a beautiful photograph, is around 55 million light-years away from Earth. We are aware that there are other black holes like the one at the heart of HR 6819. Some scientists estimate that the Milky Way alone contains up to 100 million black holes. What occurs when two black holes collide? Astronomers have speculated about this intriguing issue for more than 30 years. What happens when two black holes collide? Black holes that emerge from massive dead stars occasionally collide with one another inside of a galaxy, especially in double or multiple star systems. Even though no one has ever seen such a collision in person, it was a hot topic in theoretical astrophysics for years. It turns out that when black holes meet, a weird thing happens. They converge on one another as they spiral in the same direction. Then in some circumstances, a gravitational slingshot effect ferociously flings them into intergalactic space and away from their host galaxies. Gravitational waves, a consequence of the merger, are the cause of the ejection process. The merging black hole can be physically propelled far from the point of merger by gravitational waves. When scientists used Hubble to scan quasar 3C186 in 2017, they discovered strong proof of such a process. The offset quasar's observations suggested that gravitational waves generated by the collision of two supermassive black holes were responsible for ejecting it from the galaxy's center. But how does this mechanism contribute to the formation of black holes? Could there be a lot of black holes outside of galaxies where it would be very challenging to discover them? Meanwhile, there are two supermassive black holes that are likely to combine into one monster black hole, and they are located not far from Earth, according to astronomers using the Very Large Telescope of the European Southern Observatory, ESO. These black holes were found in the galaxy NGC 7727, which is only 89 million light-years away from our own galaxy. They differ in size and are very large, measuring 154 million and 6.3 million times the size of the Sun, respectively. Keep in mind that Alpha Centauri system is only 4 light-years away, so 89 million light-years are only close in a relative sort of way for space. The fact that these supermassive black holes were discovered is even more amazing, given that they strangely lacked a prominent radiation signature that would have allowed researchers to detect them. This may result in the discovery of numerous other supermassive black holes. Scientists have discovered the nearest pair of supermassive black holes, and they believe that by colliding, they would create an even more powerful black hole. The two black holes' close proximity and similar velocities suggest that they will join soon, likely within the next 250 million years, creating a monstrous black hole. The merging of black holes like these could explain how the most massive black holes in the universe came to be. These black holes mergers may be the origin of the most enormous black holes in the universe. What is ahead for pairings of supermassive black holes? According to researchers, the Extremely Large Telescope will provide additional opportunities to locate these couples even at great distances. This will make this kind of research more feasible in our local universe. Do we actually live in a black hole? Let's go back in time. The Big Bang occurred before the emergence of humankind, the Earth, the Sun, galaxies, and even the ability for light to shine. About 13.8 billion years ago, something occurred. But what about before that? Many physicists claim that there is nothing earlier. They believe that time started at the moment of the Big Bang, and that considering anything earlier is outside the purview of science. We will never fully comprehend what reality was like before the Big Bang, what it was made of, or why it erupted to create our world. Such ideas are incomprehensible to us. Unconventional scientists, though, are in disagreement. These physicists propose that just before the Big Bang, the entire universe's mass and energy were crammed into a minuscule yet immensely dense speck. Call it the beginning of a brand new universe. The size of this seed is estimated to have been nearly beyond comprehension. It may have been trillions of times smaller than any particle that humans have ever been able to witness. But even so, It's a particle that has the power to create every other particle, as well as every galaxy, solar system, planet, and living thing. This seed seems to meet the definition of the God particle perfectly. So how is a seed like that made? One theory that has been floated around for a while is that the universe's origins took place inside a black hole, which is arguably nature's most extreme environment and was made famous by Nikodem Poplavsky of the University of New Haven. Before we continue, it's crucial to note that many theoretical physicists now think there may be other universes beside our own in the past few decades. Instead, we might be part of a multiverse, a vast collection of distinct worlds, each having its own bright orb in the real night sky. There is significant discussion about how or even if one universe is connected to another, all of which is extremely hypothetical and, as of now, utterly unprovable. One intriguing hypothesis is that the universe's seed is like a plant seed, in that both contain an important component that is firmly compressed and encased in a protective shell. This is an accurate description of what occurs within a black hole. Giant star corpses that have become black holes, such as a star's core collapses inward as it runs out of fuel. Everything is being gripped by gravity with increasing ferocity. There are 100 billion degrees of heat. It breaks atoms, it shreds electrons. These fragments are further distorted. By this time, the star has become a black hole, which implies that no light can escape from its powerful gravitational pull. The event horizon is the line separating a black hole's interior and exterior. There have been numerous reports of enormous black holes, some of which are millions of times more massive than our Sun, at the heart of galaxies, including our own Milky Way. You can calculate an area that is infinitely small and infinitely dense using Einstein's theories to determine what happens at the center of a black hole. This hypothetical region is known as a singularity. But in nature, infinities are uncommon. The mismatch is caused by Einstein's ideas, which produce excellent computations for much of the cosmos, but tend to fail in the presence of extremely strong forces, such as those present at the creation of our universe or inside a black hole. According to certain physicists, including Dr. Poplavsky, the matter inside a black hole eventually reaches a point where it can no longer be crushed. Even while this seed is exceedingly tiny and weighs as much as 1 billion suns, it is real, unlike a singularity. Due to black holes spinning, the compacting process stops. They rotate at a rate that may be very near to the speed of light. And because of this spin, the compacted seed has a tremendous degree of torsion. It's twisted and compressed like one of those silly spring-loaded snakes in a can, in addition to being little and heavy. In other words, it's feasible for a black hole to act as a conduit, a one-way door between two universes. This indicates that it is possible for you to wind up in a different world if you fall into the Milky Way's black hole, or at the very least for the fragments of you to do so. The hole only serves as a connection, much like a shared route connecting two aspen trees. This other universe isn't inside ours. What about all of us who are present in this universe? We might be the offspring of an earlier, different cosmos. Call it the mother of all things. Even though our universe has been quickly expanding for the past 13.8 billion years, we could still be concealed beyond the event horizon of the black hole that our mother universe was created inside. Understanding massive black holes in the early cosmos may benefit greatly from more research on black hole mergers. Our questions about black holes may continue to be clarified by additional research into how black holes behave in more recent times. Pluto appears to have taken the adage "always follow your heart" literally. A massive million-square-mile nitrogen glacier makes up Pluto's heart, one of the distinguishing characteristics that New Horizons saw on approach and captured in high-definition images during the flyby. Sputnik Planitia, the left ventricle of the heart, essentially forced the dwarf planet to rotate so that the basin now almost exactly opposes Pluto's moon, Charon. True polar wander is the process through which a planetary body modifies its spin axis, typically in reaction to significant geologic processes. The location of Sputnik Planitia is not by chance. It's a cold trap where a sheet of ice at least 2.5 miles, that's 4 kilometers thick, has been formed through nitrogen ice accumulation. It physically tilted the dwarf planet so that the basin aligned closer with the tidal axis between Pluto and Charon due to the continual imbalance of that large mass and the tidal yanks and pulls of Charon as it orbited Pluto. It is also believed that this event caused the several enormous faults in Pluto's crust that zigzag across significant areas of Pluto, as well as cracks in Pluto's surface. The basin is believed to have developed closer to Pluto's North Pole and to the northwest of where it is now. And if ice continues to build up on the basin, Pluto will keep turning around. However, there's more to that tale. Pluto's surface is likely covered by a large ocean of liquid water. Sputnik Planitia may have been reoriented by more than just ice that had been collected. Scientists believe that the heavier mass may be an ocean of water, since data from New Horizons observations of the basin suggests that it may have been affected by a heavier mass beneath it. That finding was astounding. As with Titan, Europa, and Enceladus, it would turn Pluto into an elusive ocean world. There are numerous more lines of evidence that hint at an ocean beneath Pluto's crust, such as tectonic formations visible in New Horizons images. A Kuiper Belt object that was 30 to 60 miles, that's 50 to 100 kilometers across, likely struck Pluto some 4 billion years ago, carving out a significant portion of its icy crust and leaving only a thin, weak layer at the basin's floor. This impact resulted in the formation of Sputnik Planitia. The weak crust of the basin was likely invaded from below by a subterranean ocean, and later the thick layer of nitrogen ice that can be observed there today was deposited on top. Recent theories based on photographs of the planet hypothesize that Pluto may have formed quickly and violently, creating this liquid ocean. Pluto's liquid ocean is still liquid, which suggests that the planet is still tectonically active. Massive faults sever about 2.5 miles through Pluto's frozen crust and extend for hundreds of kilometers. However, one of the only explanations offered by scientists for how Pluto acquired such fissures is the progressive freezing of an ocean beneath its surface. Like an ice cube in your freezer, water expands when it freezes, and under an icy crust, that expansion will push and shatter the surface. The ice will again contract if the temperature is low enough and the pressure is high enough for water crystals to begin to form a more compact crystal structure. Pluto possesses the parameters for that kind of contraction, according to models using data from New Horizons. But there are no known geologic features on the planet that would suggest a contraction has already taken place. According to scientists, this indicates that the deep water is still undergoing freezing, which could result in the formation of fresh surface faults. If Pluto is an ocean world with active life, it is possible that the Kuiper Belt has other ocean worlds among its dwarf planets, greatly increasing the number of locations in our solar system that could support life. Although Pluto's liquid ocean probably still exists today, scientists believe it is mostly cut off by ice, with the exception of the region directly beneath Sputnik. That means it most likely doesn't make contact with the surface today, but it might have in the past though, through a volcanic process known as cryovolcanism. Pluto had a history of volcanic activity and still might. However, it may not be volcanic in the sense you may expect. On Earth, molten lava spews, dribbles, and bubbles and explodes via volcanoes perched kilometers above and jutting out from the waters, like those in Hawaii. On Pluto, however, there are multiple signs that at different times a form of icy, slushy cryolava has spilled over the surface. They refer to it as cryovolcanism. Two massive mountains south of the Sputnik Planitia, Wright Mons and Picard Mons, both have deep center pits that are thought to be the mouths of cryovolcanoes that are unlike any others in the solar system. Viking Terra, which is located to the west of Sputnik, has extensive grabens and cracks that indicate signs of once flowing cryolavas all over the surface. The Virgil Fossae region, located further west of Sputnik Planitia, is where ammonia-rich cryolavas appear to have burst to the surface and covered a region of several thousand square kilometers in red-colored organic molecules no more than 1 billion years ago, if not even more recently. Speaking of current events, Pluto's surface is still covered in glaciers, which have been doing so for billions of years. Pluto now joins Earth, Mars, and a few other moons in having glaciers that are now flowing. Numerous, mainly nitrogen ice glaciers stream down from mountains with pits into the basin to the east of Sputnik Planitia and carve down valleys as they go. The source of the ice in the glaciers is thought to be seasonal and mega-seasonal cycles of nitrogen ice that sublimate from ice to vapor, drift around the dwarf planet, and then freeze again on the surface. However, these glaciers differ from the water ice glaciers we have on Earth. For starters, because liquid nitrogen is less thick than solid nitrogen, any melts within them will float to the top rather than descend toward the glacier's surface. It's even possible that some of the liquid nitrogen may even erupt as jets or geysers as it emerges on top of the glacier. In addition, some of Pluto's surface is made of water ice, which has a somewhat lower density than nitrogen ice. Some of those water ice rocks will rise up through the glacier and float like icebergs as Pluto's glaciers sculpt the surface. Sputnik Planitia, the largest glacier known to exist on Pluto, measures more than 620 miles, that's 1,000 kilometers across, or roughly the size of Oklahoma and Texas put together. These icebergs can be seen in several images taken by New Horizons of Sputnik Planitia. Meanwhile, the atmosphere of Pluto is slowly disappearing. A recent study suggests that the gases surrounding Pluto are now dissipating and turning back into ice as the dwarf planet moves farther from the Sun. Holding on to your atmosphere as a celestial body isn't always easy. Just ask Mars, and the new study suggests that this is happening right now. With only a trace amount of methane and carbon monoxide, Pluto's atmosphere, which is already on the thin side, is primarily composed of nitrogen. The atmosphere appears to be fading as a result of nitrogen freezing up once more as surface temperatures plummet. Utilizing occultation, which involves utilizing a far-off star as a backlight for telescopes on Earth to observe Pluto, the judgment was made. It is a tried and true observation method that is frequently employed in astronomy. According to planetary scientist Elliot Young of the Southwest Research Institute, SWRI in Texas, scientists have been using occultations to track changes in Pluto's atmosphere since 1988. Small changes in temperature cause large changes in the bulk density of Pluto's atmosphere, which is formed from the evaporated ice on the surface. The dwarf planet currently completes one circle of the Sun in 248 Earth years, traveling as close to the Sun as 30 astronomical units (AUs), or 30 times the distance between Earth and the Sun at one point. However, when that distance widens, Pluto will receive less sunlight and experience colder temperatures. The increase in atmospheric density seen in 2015 is probably the result of thermal inertia, or leftover heat trapped in the nitrogen glaciers that have a delayed response to the enlarging distance between Pluto and the Sun. This can be compared to how the Sun warms beach sand. High noon is when the Sun is at its brightest, but the sand continues to absorb heat throughout the afternoon, making late afternoon the hottest time of day. Pluto may no longer be considered a planet, a point of considerable debate among specialists, but astronomers continue to be very interested in it as a planetary entity. We are always learning new things about this far-off rock. The planet may appear brighter in the sky if it eventually freezes and falls because it would reflect more sunlight. Also, the lack of small craters on Pluto and Charon has important ramifications. It's kind of common in space to discover craters on the surfaces of planets. The fact that neither Pluto or Charon contains many tiny craters, nearly all of them are large, is the only unusual feature of the Pluto system. The fact that there were fewer small craters than anticipated startled scientists because it implied that there are also fewer smaller Kuiper Belt objects than anticipated. These findings help us understand how the solar system came to be, since they provide information on the population of smaller objects that make up larger ones, like Pluto and potentially even Earth. We encounter unexpected phenomena that refute established hypotheses every time we explore a new region of the solar system. Two distinct terrain types can be found on the side of Charon that New Horizons images in high resolution. A vast southward extending plain officially known as Vulcan Planitia that is at least the size of California, and a rough terrain referred to as Ozterra that extends northwards to Charon's North Pole. Both appear to have been created by the freezing and expanding of an ancient ocean that existed beneath Charon's crust. While the expansion in the south made its way through vents, fractures, and other openings as cryolava pouring across the surface, moderate expansion in the north developed that rocky mountainous environment of Ozterra that is visible today. In reality, it's believed that Vulcan Planitia originated as a massive cryoflow that engulfed the area early in Charon's existence. Similar features can be found on a few ice satellites throughout the solar system, notably the enormous moon Triton of Neptune, Tethys, Dione, Enceladus of Saturn, and of course Miranda and Ariel of Uranus. The models of Charon's past will also serve as a Rosetta Stone to help in deciphering the volcanic and geologic activity of those other frozen worlds due to the detailed photographs of Charon taken by New Horizons. Pluto underwent a transformation thanks to New Horizons, going from a fuzzy telescopic dot to a vibrant world with astounding diversity and unexpected complexity. We are all astonished by the variety of phenomena present throughout the Pluto system, from Charon's polar features, an enormous chasm, to the four smaller satellites' ice ball composition, which provided important hints about the system's beginnings. Thanks for watching another episode of Voyager. While you're still here, make sure to click the video on your screen for more mind-blowing videos about space.